Hey, we are studying families of graphs. Remember yesterday? It's the same thing, basically. You remember what a constant function looks like? Yeah, but how's it oriented? Okay, so it's a flat line. Straight across. Remember, be quiet, ladies, please. Linear functions, quadratics, cubics, quartics, and quintics. Those are the polynomials from yesterday. We have the square root function, the absolute value, greatest integer, and rational. All of those graphs can be manipulated using transformations. So I'm going to go through a few examples just to show you what happens when we use those transformations with graphs. All right. Let's go with, okay, we have what's called a parent function. Yes, parents are fun. Not your parents, right? I'm going to use the square root of x. Since that's one that's not really familiar to you. Okay, that's what the square root of x looks like. That's called our parent function. What if I did something like that? What if I multiplied it by 2? Neither. Thank you for the correction in language. This multiplies each y value by 2. So is it gonna? It's just gonna either. So 0 is gonna be the same, right? But what is this point at 1 gonna have to do? It's gonna, instead of 1, 1, it's gonna be 1, 2. Okay, and 4 is gonna be, instead of 2, it's gonna be 4. 9, the square root of 9 is 3. Instead of 3, it's going to be 6. So it amplifies the function. So this number here makes the graph taller or shorter. If it's a fraction, it would make it shorter, right? Okay. On some others, it'll make it skinnier. Or fatter. Okay? Just like eating too much food. You get a little bit large.
What makes it skinnier and fatter?
That number in front. I'll show you an example there on a different function. What about something like this? What if I do that? Do you guys remember what that would do? It's the square root of x plus 2.
I don't know. What do you do? The number and plus 2 is square root.
Okay, it's inside the square root, so it's going to move it left or right? Wrong. Left. So If it's inside the square root, it's left or right. You're going to notice that same pattern if it's inside a squared or a cubed or any of those. If it's with the main operation, it's going to do it just so, and it just moves everything to the left too.
All the time moves it to, or is that just
Okay, it takes the blue parent graph and moves it to the left 2 spots. Okay, what if it was x minus 2? Which way would it go? Yeah. Yep. To the right. Okay. You with me?
no?
All right. Why are you confused?
I don't understand. How do you, are you saying you're going to give a value to that, or what?
Yeah, so if I plug 0 in here, 0 plus 2 is 2. Square root of 2 is 1.414.
Okay.
Or if I plug 2 in there, it gives me the square root of 4, which is 2. But what I'm trying to teach you guys is to know what the parent graph looks like. That's this one. And then use these properties just to shift it left, right, up, down, shrink it, or expand it, so you get a sketch of the graph.
Is it always going to be the parent function? Is it always going to be y equals x?
Oh, it could be y equals x squared or y equals x. Any of those.
Parent function.
Yes. Okay. What if I have the square root of x and then plus 3 is outside it? Which way is it going to move it?
Right.
No, it only moves it left or right if it's under the square root. Okay, so this is up 3. If it's negative, it'll move it up down. So I'm just going to move this up 3. Every one of these dots. Okay. So it just takes the parent graph and shifts it up. What if I did a negative on that front? So let's just make sure that's good. What happens if I make that 2 a negative? Right, but what's it going to do to the graph?
Shift it right,
Nope.
left,
If I do
I don't know.
y equals negative 2 root x.
Would we be like going down and up?
Yeah, Jared got it. It's this graph down. Okay. Okay, the negative reflects it over the x-axis. It's another way to manipulate it. You want me to do one you're a lot more familiar with?
Sure.
Okay. Quadratic, absolute value. Take your pick.
Absolute value.
Okay. You know how to graph the absolute value of x, right? Yeah, that's a little bit messy, but that's our parent function, located on the origin, right?
What's the slope of those? What are the slopes of those lines? Yeah, 1 and -1. Right. So the slope here is 1 or -1 because of the absolute value. What if I did this? Put a -1/2 in front. It's multiplied, not added or subtracted. Movements only occur with add and subtract. What does the negative do to it? Okay, it's upside down. And what's our new slope? 1/2. Yep. So down 1/2. So we're going to down 1/2. So we're going to reflect it over the x-axis, and we have a new slope. Okay. So again, as with the first one, the 2 or the -2 changed it with this. It's steeper. You know, on this one it's steeper, or you flip it upside down. Okay. Logan, is that making more sense?
Yeah, that helps.
Okay. Let's try this one.
Right too.
Okay, it's inside the bars, right? Inside the bars means we move left or right. Somebody said it?
I did.
To the right 2 units. Be careful on that, because it's the opposite of what it shows. If it's -2, you have to move it to the right. Okay, so inside the bars or the squared or anything of that nature. You with me still on this one? What about, let's try a 3 plus 3 outside the bars. Up 3. So it's outside the bars. Up 3. So it's the same as the parent function. We've just translated it 3 units up. So you get the idea. All you're doing is taking the graph and moving it around, or shrinking it, or expanding it, flipping it over. So my hope here, one, you know what the parent graph looks like. Okay, so the parent graphs you know what that one looks like, right? Y = x. Are we paying attention? Because about half of us aren't. Okay, you know what y equals x looks like? Yeah? I went through all these yesterday with you. Do you still want me to write them down? X squared, x cubed, x yada yada yada. I'll write down the biggies. Okay, another parent graph. You've got the square root already. You've seen absolute value. Oh, rational. There's your rational. Those are the big ones. All the ones that I've shown you today. We just went through that, Logan. These are the parent and child relationship. Okay. These are parent graphs. The children are results of shifts, translations, reflections, etc. So you have the parent and the child. Do you have any questions? Okay, later's fine.